Good morning, everybody, and welcome to this UKSTT Trenchless tea break on the topic of British Standard 9295, structural design of buried pipes. I'm sure the standard is very familiar to many of you. It's a well-established standard that's been in use for many years. The topic today is on the direction of the standard and possible changes. And we have two presenters, both of whom are members of the relevant BSI committee that is dealing with this particular standard. They're actually speaking in the opposite order from that shown. So the first speaker will be Sandra Rolfe Dickinson. Sandra is the Technical Director of Pipe Technics Limited. She's a chartered civil engineer and also a registered professional engineer in Ontario in Canada. And she specialized in pipeline engineering, design, condition assessment for probably some 30 years or so. And our second speaker will be Phil Clisham. Phil is a chartered civil engineer, also specialized in water and wastewater networks for some 30 years. He's a past chairman of the Pipeline Industries Guild and has been on the Guild's technical panels for more than 14 years. As well as this particular BSI committee for BS9295, he serves on other BSI committees and also Syria standards committees. So each of the speakers will talk about their particular element of this standard and where it's going, and then we'll have a question and answer session afterwards. So first, Sandra will talk about recent improvements made to the guidance in the standard and future direction. So I think now, Sandra, you just need to share your screen and we'll get going.
Thank you very much, Tom. Good morning, everyone. As Tom said, my name is Sandra Rolfe Dickinson, and I've served on the British Standard Committee for more than 10 years. And what I'd like to do this morning is to basically run you through the history of BS9295 and how we got to where we're at presently with this standard. It doesn't seem to be, there we go, press the right button. So just to give you a bit of background on EN 1295 Part 1, which was the initial standard that basically held the UK's design method. Commencing in the 1980s, there was a primary purpose of the task group, Joint Working Group 1, which was members of the SEN committees TC 165 and TC 164. And the primary purpose of that group was to attempt to produce a single pipeline design method which could be used across Europe, and also to set pipe product characteristics needed to facilitate design. So the attempt to agree a common method of design that could be used across Europe really was not successful, but over the 10 years or more of trying to get output from the joint working group, the main outputs were the standard EN 1295-1, which summarised basically the common ground of the standards and listed the national methods with descriptions in informative annexes. And actually the UK procedure for structural design of buried pipelines was added as an annex to that particular standard. The UK annex was heavily based on the Marston-Spangler principles for the design of rigid, semi-rigid and flexible pipes. But we found as new plastics pipes came onto the market and new materials were developed, such as structural wall plastics and large diameter, low stiffness plastics, some of those methodologies were not well suited to describing the behavior of those pipelines. And the established methods were really more suited to GRP and UPVC rather than polyethylene. Also published by the joint working groups were TR 12952, which was a summary of the nationally established design methods, TR 1293, which was a common method or attempted to be a common method. This was ostensibly based on the French and German design methods. and then later TR 12954, which gave parameters for the reliability of design. An unintended consequence of the UK having its design method as an annex to the European standard was that it meant that really that design method was fossilized in that process. So in 2010, we developed BS9295, which was basically a standard which attempted to be a guide to EN 12951. So what we found was that the standard, if you're familiar with EN 12951 and the annex therein, it lacked any detail or any explanations which we felt were necessary to give designers a better understanding of concepts. So 9295 was written really to help explain concepts such as wide and narrow trench design, incomplete and complete projection, and it also gave guidance on how the basic formula in the standard should be used. And it reduced the need for cross-referencing and became a standalone document but acknowledged 1295. So it didn't replicate what was in 1295 but kind of added to it. Another purpose of that document was that it sought to capture material in other documents that are sort of long passed into the annals of history, such as documents like TRRL, a design guide to the design loadings of buried rigid pipes, which contains a lot of good information, which we didn't want to be lost. The standard was really constrained by the fact that it wasn't allowed to conflict with the European standard, and this meant that we were prevented from developing some of the more modern research that I mentioned around the large diameter flexible pipes and workmanship, those sorts of issues. So we needed to find a way really of delivering some of those things that we felt were missing. And really key to that was the uncoupling of our national design method with that European standard. So in 2019, there was a new version of 1295.1, which was published, and the UK successfully argued the need for this revision to remove the content that had been perceived as really inhibiting the development of our design processes. This revised standard was published in 2019, and the annex that contained the UK method was dropped. So this now meant that the UK could develop its own design procedures without having to keep asking the Europeans to update the European standard. So that sort of decoupling occurred and gave us more autonomy over our design method. So now the new the new EN 12951 references BS 9295, rather than previously it had been the case that 9295 had to reference the UK annex. So like I say, that link was broken and we had more autonomy to develop the standard as we would wish. So following on from that, 9295 was then updated. A new version was published in 2020, and this was the culmination of a review of the UK current design methodologies, and it also included the publication of a new design method, the Gumbel method, which is a procedure for the design of large diameter flexible pipes. And it was aimed and developed originally for basically looking at large diameter structured walled plastics, but in fact it can be applied to any homogeneous pipe material. Whilst we were doing work on this standard, what we identified inevitably were a number of weaknesses and omissions that we felt existed within the standard. Some areas where the design basis was perhaps not wholly appropriate, and basically there's been a core group of consultants and academics from the BSI committee who've continued to develop their thinking around these omissions and weaknesses, and really we're looking to see if we can plug those gaps and get funding for further research so that we can better understand some of those issues. At the moment, 9295 has no specific references to trenchless installations, and we feel this is a real omission. And that's one of the reasons that we're presenting here today, really, is to get your feedback and feelings about how we might incorporate some Trenchless references into another update of 9295. So really, where we would seek your help really is to understand the established design methods that currently exist for Trenchless technology. We know of some of them. Phil, in his presentation shortly, will just touch on the ones that we're aware of and where they're used and what we perceive as some of the shortcomings. But we really would like to know what your feelings are about research needs, and some of the things that we've come up with are things like soil loads on trenchless pipes, residual stresses and strains from installation operations, long-term variation in soil loads, and any other key needs that you think are not adequately covered in the current work. With the ultimate aim that we would like to include guidance for the structural design of trenchless installations in the next version of 9295. So that really concludes my summary of how we've got to where we're at, and I'd like now to pass over to Phil, who will go into a bit more detail on some of these issues. Thank you.
Thanks, Sandra. I shall try and launch my slides. Can everybody see that? Well, I shall proceed then. There we go. So, as Sandra has pointed out, the current version of BS9295 has no specific references to structural design for trenchless installations, and we'd like to include some because it's the guide to the structural design of buried pipes, and we ought to have some guidance in there for those installed by trenchless methods. Now, one of the underlying if you like, principles behind the development of BS9295 is that, and 1295 before that, was that we don't want to overcomplicate anything. We don't want to load the industry up with having to do calculations that are not necessary. So we want to try and keep things simple where it's in, where that will do, and add complexity where it's justified, to make sure things don't fail. So we want to keep that simple approach and apply that. We have simple lookup tables for small diameter pipework in the current guide, and wherever those principles can apply, we would like the same. So I'll try and illustrate that through the talk. The point is, if you overload pipes, they will fail, and we need to be able to know to work out how to calculate loads on pipes installed by trenchless techniques in the short and the long term. And it's the long term ones that we're less comfortable about, if you like, with the current processes. And how do you assess the support that the pipe surround's going to get, from the earth around it? And that varies according to technique. Why are we bothered? Well, inevitably, and what we're seeing as trends, is that the larger diameter pipes are being installed trenchlessly. The techniques are evolving, and this trend will almost certainly continue. There's a massive drive to reduce carbon costs, and this is almost certain to result in an increase in the number of trenchless constructions, many of which might be quite shallow. We might not always be deep, and in all kinds of different ground conditions as these techniques evolve. And as for all works, pressure is being applied to reduce wall thicknesses and push boundaries to save money and carbon. And as you push boundaries, you can easily find yourself on the wrong side of boundaries and in trouble. And this is what we want to try and help the industry to avoid. But they do fail. Tunnel liners certainly fail. And we need to understand what the limits are and why, and what guidance applies and why. So in order to try and illustrate some of the issues, I'm going to play a video, and this will outline the considerations we have for pipes installed by normal open cut techniques. So in this case, we've got a flexible pipe, because we've chosen one example rather than the rigid, and it's not a particularly stiff flexible pipe, so it can't handle very much load on its own. What we're now going to do is add some pipe embedment. And in this case, it's a nice class S1, a single-sized stone, which flows beautifully. As you can see, you pour it in at the side and it flows right underneath the haunches of the pipes and fills that narrow little gap up. So this is your pea gravels, your Rolls Royce of pipe embedments. It doesn't need compaction, it self-compacts. So we're under pressure to use less and less of this because, of course, it's imported and has an embedded carbon content, and that has its own implications. But as you can see, it's very effective. We can now pile quite a lot of load on that, and that pipe transfers a load through the bedding and into the, in this case, the glass fish tank. It could be a rock trench, and it can carry really great loads. If we, just to illustrate, if we change something in there, in this case, we're going to remove the rock trench and we're going to put what is foam. This will simulate softer ground. So if we have a softer embedment with the same softer natural ground with the same embedment and the same pipe, what effect does this have? So again, we're going to pour the single size gravel in. Now, as an industry, we're under pressure to use selected as dugs and get materials that flow underneath the pipe and behave like this, and then the compaction of them. There are all issues with that, where I think we do need to raise our game, particularly in the UK. But to keep things simple, that's what we've used in this case. And of course, we load that up, and it still carries a lot of load, but the softer natural ground provides less support. And as you load it up, it can carry less load, and the pipe fails to transfer enough load before it flexes too much. So we could run through these for rigid pipes and others. The point is, for the structural design of buried pipes, it's a combination of the pipe embedment, the natural ground, and the stiffness of the pipe itself. And for trenchless installations, it's probably the same. As you say, rigid pipes behave differently, and if I had the time, I'd go into a bit more detail on rigid pipe behaviour. So this is your concretes and your clays to the flexibles such as polyethylene and thin wall steels. So how does this differ from trenchless installations? Well, there are two key differences. One of which is the trench itself means that you've got a load on the pipe, and some of the biggest elements of those, particularly for deeper installations, come from the backfilled trench and the ground above it and the weight of that. With trenchless installations, if you happen to have installed it through rock, well, the rock can span that completely and will shield the pipe from a lot of the loads from the natural ground. It probably won't from groundwater, but that's quite an even spaced load, and you get a compressive load all the way around it. But if you're in sands or clays, over time, loads can increase, and it can have an increasing load on the pipe, or you can see an increasing load on the pipe over a period of time. So it depends very much on the ground. The other key difference is the pipe embedment that can be nice and neatly compacted round. With tunneling, you tend to have an overbreak, which is grouted up or filled in some other way. So there are significant differences. Now, we've been tunnelling for centuries. I think the first tunnel underneath the Thames was in 1847 by Brunel, and we've been doing research and tunnelling miles and miles ever since. So there is a very well-established process for design of tunnel lining, and the one I use the most is the Institution of Civil Engineers. The British Tunnelling Society sits within the Institution of Civil Engineers, and it has a guide dedicated to the tunnel lining design. Now, I've just extracted a certain paragraph which illustrates this quite well. But tunnel lining design is a challenging task, not least because of the variability of the ground. The designer may use a variety of design methods in order to gain an appreciation of how the ground and the lining are likely to interact. And if you look at the last paragraph, it's recommended that several design methods will be used when designing a lining, since the other design methods will provide an independent check of the main design method. So a lot of analysis is done for tunnel linings. I mean, the big assets, they cost hundreds of millions of pounds. A lot of analysis is done. There's whole conferences held to discuss lining designs and issues and analysis. And this is all based on extensive research from around the world, yet failures still do occur. Do we want to apply this to every trenchless technique, and where should this apply and where shouldn't it? If you look at pipe jacking, the Pipe Jacking Association also provides guidance, which is useful. It tends to focus its guidance on the short-term stresses and strains that apply to the pipe as a result of the jacking process. So these tend to be the shorter-term ones, and I've always understood that the longer-term ones, you refer back to the BTS, the British Tunnelling Society guidance, to look at those and to ensure that whatever you've got will be up to the loads that apply to it. When it comes to auger boring, to me, this is a form of pipe jacking, but it is quite different. And some of these are getting up to 1600mm diameter. They're not all small diameter, and some of you guys might tell me they're getting bigger still. And these tend to be thin wall steel pipes that go in as liners. There's less overbreak, and there's very little guidance that I'm aware of on how to deal with the design of these liners from a long-term perspective in particular. Horizontal directional drilling is different again. The most comprehensive guide that I'm aware of is the American Society for Testing and Materials, ASTM guide. In this case, it's 1962, F1962. So this does cover long and short-term loads on pipes installed by horizontal directional drilled techniques. And the guidance is very good, but by its own admission has its limitations. And the quote there in italics is, as the earth load applied to the directional drill pipe is dependent on the depth of cover, borehole diameter, mud slurry properties, drilling and back reaming techniques, and the in situ soil properties, among other things, a geotechnical engineer should be consulted. Is this the best guide out there? Are there better? Key differences between horizontal directional drilling installation and some of the assumptions based on the BTS type guide for tunneling are things like the overbreak. For a standard tunnel and pipe jack, the overbreak is normally about 10% of the pipe diameter. For horizontal directional drill installation, it's normally about 50% of the pipe diameter. So you've got an awful lot of overbreak, and what you fill this void with will have a big impact on the pipe's ability to carry load in the future. So that overbreak is different. With horizontal directional drilling, flexible pipes are normally used, and these are normally polyethylene. And there's also a lot of stresses and strains imposed on the pipe with some of these longer installations in particular, which need to be taken into account. And it's how the polyethylene behaves as a result of these, which can be both positive and negative. So are there better standards and guides out there, or is this the best? That's the question that we don't know and would like an answer to. What is the latest research, and what has been done and is more needed? How should residual stresses and strains from installation be taken into account? Is the guidance in things like the American ASTM guide sufficient? And then we've got things like direct pipe installation, which is a hybrid between pipe jacking and directional drilling, which again, 1600 diameter steel pipes. What work do the same principles apply to this, or is this different again? So this is a plea. We now have control of this structural design of buried pipes in the UK. We can take it where we'd like to take it, and we would certainly like to improve it. And one of the areas where we'd like to improve it is trenchless construction. Why? Because it's going to grow, and we believe the industry needs it. Guidance exists for design of liners for traditional tunneling, but this is complex. And it's probably over the top for a lot of installations. So where should we switch to this, and why? At what point? And is there a simpler method, and what is it and why? Should we adopt the ASTM approach for horizontal directional drilling, or are there better guides out there? And what should we need to do? What should we do? So what do we want from UKSTT and its members? Well, we would like to be sure that where we go with this is right and is based on the very latest research and the best guidance that's out there. And so ideally, we would like to be able to fund a comprehensive desk study to find and understand the available guides and assess them, and particularly concerning the structural design in the long and short term, both. And we would then be able to complete any gap analysis, which may lead to additional research. But the aim is to provide useful guidance on the structural design for pipes installed by trenchless techniques that doesn't impose an unnecessary burden on the industry, but does help us avoid problems. And and help would be grateful received in that front. So that's the main purpose of the talk, and certainly Sandra and I are open to questions. I'll hand back now to Tom.
Thank you, Phil. That's a very comprehensive coverage. Let's go back to my screen. There is, I should have said this at the beginning, there is a Q&A function, which you should have on your screens. On mine, it appears at the top. You can either put them in there or put them in the chat. Any questions for either Phil or Sandra, or discussion topic, something you'd like to contribute? Now, please go ahead. I think we've had a very comprehensive view from Sandra of how we've got to where we are with BS9295. You did say, Sandra, that the standard was updated in 2020.
Yes, that's correct.
What is the timescale for the current review?
Oh, that's an excellent question, Tom. Unfortunately, the edition that was published in 2020, we have found a few little things that are not quite correct. So we are actually in the process of going through an amendment at the moment, which we're hoping will be published fairly shortly, a bit dependent on BSI for that. But I think Phil will correct me. We're keen to be able to do a more comprehensive update probably in the next 3 to 4 years.
Yep.
And as Phil said, we need to understand what's out there. We're not aiming to replicate equations and the like in 9295 if there is a good reference that we can just make a reference to another document. I think that would be our preferred way of handling any new design procedures, rather than, we don't want to sort of just replicate things and then be in the position where if the reference document changes, then we've got to do an update. So we would much rather reference established methodologies if they exist. I don't know, Phil, if you've got anything else to add.
It's just the principle really is what provide the industry something that's really useful, that doesn't impose an unnecessary burden on the industry. So we don't want to force people to do unnecessary calculations. If we want to keep things simple where it's right for them to be simple, and but if it's necessary, and some of these crossings that have been installed trenchlessly now are vital crossings. The implications of failure are really quite serious, and so they have to be right. And so it's the appropriate level of work needs to go into them, and it's what guidance we can offer and how we can steer people through that. If that's a matter of, at this point, really you also referring to the BTS type of approach, then that's it. But what do you do for simpler installations, and is that really necessary? So we're open. It needs to be good guidance that's really useful. That's the principle, and simple where it can be kept simple.
But am I right in thinking that this remains a guide rather than a prescriptive standard from what both of you have said? Would that be correct?
It remains a guide, but once it's out there as a published guide, it does have legal status, and so if you ignored it, you've generally got to have good reason to ignore it. So you don't have to use it, but if the thing fails as a result of not using it, you're still in trouble, basically.
Oops, I didn't mean to go that way. I'm not seeing anything coming up on the Q&A. I didn't mean to go that either. So I'm not seeing questions and answers on my screen. So I'll carry on with a couple of other points. Phil, you mentioned, looking at other design guides and things like that. Is there any perception within the committee of based on what you said, these are high risk and we don't have great design methods. Here we are. A question has appeared. We don't have great design methods. Is the likelihood then that people are over conservative in the designs at the moment because we have no option?
What we perceive is going on is that there's a lot of work being done on the short-term loads and the installation loads, and that perhaps very little is being done on some of the longer-term loadings that may apply. And if the pipe's strong enough to deal with the installation loads, it is very often strong enough to deal with the longer-term loads. It's spotting the circumstances when it might not be. And that's the concern, in that as we push boundaries and push these techniques into areas where they've not been used widely before, that we start to get into trouble as a result on what are quite important assets that can ill afford to be allowed to fail. Mm-hmm. And that's what we want to try to avoid. So it's the long-term loads that we fear. And of course, the guidance is all over the place, and it's left to the judgments of professional engineers to decide when things apply and when they shouldn't. And even certainly in my past lives, I would have welcomed guidance from the industry to steer me through some of the material that's out there.
Yeah, I think there's been a perception that the installation loads are the critical ones in trenchless, and if the pipeline survives those, then you don't have to worry about the permanent loads to a certain extent.
Which in a lot of circumstances, I'm sure is correct.
Yeah, but it can do with verifying.
It could, and there could be some when it's not correct, and I fear that there are. Right. As they find in tunnelling, they do fail sometimes, despite all the work they do.
Yes. Good. We have a couple of questions from participants. I'll go with the first one. Is from Samuel Williams, and it refers to the ASTM F1962. Samuel says, I haven't used ASTM F1962 yet, but I'm planning on using it on a current project. It seems to me that the formulas for calculating pulling stress, which allow for the capstone effect, take an average radius for the pipe profile. I believe that you'd end up with a much higher capstone friction force if you minimize the bend radii than if you minimize them, perhaps maximize rather than minimize, it should say. Could the formulas be improved? Do either of you have enough knowledge of F1962 to comment on that?
Certainly from my point of view, I don't know if you have, Sandra.
I haven't used it in a live situation, let's say, so I'm not that familiar, I'm afraid.
Okay, so certainly in my experience, I'm normally working with a specialist contractor, and judgment calls are quite often made on where the drill's going to be and why, and depending on the ground and the exact shape of it. And I say all the short-term loads, there's some very knowledgeable people out there that may well be on this call that we work with, and those people do work, do some very clever things in difficult circumstances. It's the longer term loads that we suspect are perhaps not always given the attention that they should be given, and as diameters increase, they get ever more sensitive to them.
Yeah, not okay, but we don't have enough experience, as you say, of F1960 to really answer that question more directly. Okay, thank you. Second question from Nick Preston. Given all the trenchless diversions on HS2, will any revision or update be too late?
Always too late. We want this 10 years ago, 20 years ago. So assuming we'll go on building pipelines, trenchlessly and otherwise, then just the sooner we get there, the better.
Yes, I agree. I mean, I think specifically for HS2, probably we won't get anything in the very short term, but as you say, we'll be doing this for decades to come. So I think anything we can do will be very useful.
Yes, and given the point that I think Phil made about increasing pressure on carbon emissions and a lot of commitments to net zero carbon in the next 10 or 15 years, that drives everybody towards trenchless. So the importance of this update and including trenchless methods in the BS is paramount.
Yes. And when you come to things that diversions, Tom, I mean, there are all kinds of issues there where, I mean, there's lots of areas where we'd like to improve BS9295. And if you put a socking great big embankment over a pipe you just diverted, it can cause quite a lot of consolidation and compaction of the ground underneath, and any pipes in there will be taken with that and affected by it, sometimes catastrophically. So there's lots of things to consider when projects like HS2 are going ahead, and other major highways and rail projects and infrastructure projects that could be better covered and are left to, you know, senior and principal engineers to consider from a first principle perspective.
Mm-hmm.
So
okay, thank you. Going back to the previous question on ASTM 1962, Nick Preston has helpfully added a comment. It basically says, Samuel, yes, you do. The capstan friction force is related to the minimum radii. So it would seem that there is a relationship there, and potentially, I'm not familiar with the document, but potentially there's a formula in there that takes account of that. So thank you, Nick, for that. We have one further question in the chat from Pete Forbes. Excellent question. Would there be a value in a future version of BS9295 covering scenarios such as more than 2 pipes in a trench? Either of you like to comment on that?
I think in the annex, or the appendices rather, to 9295, there is guidance for multiple pipes in trenches, and I think you can just kind of multiply up the effects as you add more pipes in trench. I think that came from the old TRRL guide, so I'm not quite sure how up to date that is. I don't know, Phil, if you've got any further thoughts on that.
There is guidance. We're particularly concerned about these huge storage tanks that get built, which work very well, but you've got to be mindful if you've got multiple pipes with often, minimal gaps between them. And so if you get eccentric loads, they will load each other up, and that can and does cause failures sometimes. And you've got to be very careful how you install them. So there's some guidance. We could certainly do with more. The guide cross-references to BSEN 1610, which is the construction of drains and sewers, and that gives additional guidance on minimum gaps between pipes, etc. So yes, there could certainly be more, but there is some guidance on that side of things within the current version of 9295.
Okay, thank you for that. For the moment, that's covered all of the questions that have appeared, but we still have some time. So please, anybody who has a burning question or a comment, please use the chat or the Q&A function. We're in a fortunate position with this British standard because of the way the relationship with the European standard has changed. That, as Sandra rightly pointed out, we have a lot more autonomy now over the design methods without being constrained by the sort of the EN standards. In a different context, I also work on EN standards, and getting them changed works at a glacial pace. So we are in a position now to organise this for ourselves, and we should take advantage of that. Got another answer for Sam. This, I'll read it out, is more of an answer than a comment, from Ross Henderson. I believe Ross is one of the large HDD contractors. To answer Sam's question, smaller radii will result in higher capstan loads than larger radii. Designs are based on theoretical radii. What radius is actually achieved during construction may vary and may change throughout the development of the entry and exit curves, and recalculation may be required. I think that echoes some of what you said, Phil, on it's not something you can predict at the outcome, because you have to catch up with the reality in the field, which is never, we all draw lines on drawings, but we all know that's not where particularly with HDD, that's where the pipe is going to end up. So thank you, Ross, for that comment. In the absence of any more questions, I'll try and wrap this up. I think the key takeaway is the very end of Phil's presentation is that, you know, this is a plea from the relevant British Standards Committee for contributions in terms of knowledge, known design standards, information that people have to contribute this. Initially, funding for a desk study is what the committee is looking for, to find all the relevant information. So I would urge anybody who has a particular interest in this, either through UKSTT or directly with the relevant British Standard Committee, to make contact. Any contribution in terms of information, documents, design knowledge will help the whole discussion. And the more people that contribute to that, the better. Even though the more that contribute, the more work it makes for the committee, but you end up with a better result. So please pick up on that plea. A lot of work has been done already. We have an opportunity now to influence the direction of this standard so that it includes trenchless, but does it, as Phil said, properly, rather than imposing something on the industry which is not what we want or not what we need. So please do participate. On that note, I'd like to thank both Sandra and Phil for spending the time both today and in preparation. It's been an excellent overview of where we are and how we've got here and where you want to go with this standard. I've certainly learned a great deal, and I hope that everybody else on this call has as well. So thanks to both of you for all the work you've put into this. Just a reminder, on the screen there, you see that, you know, there are technical resources at UKSTT at the website. You can submit technical inquiries, and equally anybody who wants to participate in this process with the BS9295 committee, we can make the contact for you to do that. Question and answers we've pretty much done. Just a reminder of the next Trenchless Tea Break webinar, so similar format to this, is actually a week yesterday, so just next Thursday, again at 11 a.m. And this is on transferring minimal excavation methods. UCWIR, the UK Water Industry Research, have published some guidance on minimal excavation methods. And the speakers there, Jeremy Heath from SES Water, Leo Carswell from WRC, and Joe Parker from Watershed Associates, were all involved in that process and in developing that guidance. And it will be a very, as today was, a very informative webinar to bring us all up to speed on the direction of use of minimal excavation methods and how they sit alongside trenchless methods. So if it suits you, fits in your diaries, please do join us again next week for that. And with that, again, with thanks to Sandra, with thanks to Phil, and from the UKSTT, thank you all for participating. I hope you found it interesting, and thank you and goodbye.